question today. Okay. Okay, so we are doing the lecture one, right?
Yes, sir.
Yes, sir.
We need to
Yes.
complete till slide 33.
Thank you. The information. Okay, so here we are. That DRAM, up to the DRAM we have done, right? As I say that actually the SRAM and DRAM, these are the things mainly we are going to be discussed in detail into that the RAM chapter. Um, Later on it will come. Yes, here we are talking about a bit about the SRAM. We are only talking about actually the cache memory, so that the cache memory we are having into that the processor that actually we call the this is actually the SRAM, one of the SRAM we are having in the computer system. So I already talked about that actually how the cache memory is going to be improve the operation of the CPUs. So yes, I mean it is a middleman uh, between that the CPU and that the between that the RAM. So it is going to be the middleman who is going to be help the processor to do the operations quickly. So yes, it says cache memory improves the processing by acting as a temporary high-speed holding area between the memory and CPU. So this is what I mean. I already explained to you that how the cache memory is going to be help CPU. It's like the sisters in the operation theater. It's like the sisters beside the doctor that actually who are helping the doctor to complete an operation. So that is what in advance the cache memory actually is going to be inside of that the processor. So whenever the CPU is doing something, so the cache memory in advance are going to be have some operands that may need by the CPU to complete the operation. So that is what I mean. The cache memory is very useful because if there is no cache memory, then an operation doing by the CPU and he needs an operand for continuing his operation, he must need to be paused and he must need to be go to the RAM, and until he gets that the operand, the CPU must need to be wait. So when he gets that the operands, only that time he is going to be able to restart that the operations. So this is actually that the time unnecessarily that the CPU is not doing anything when he is requesting for an operand from the memory. So if it is in the cache memory that the operand the CPU is looking for, then immediately he will get it from the cache memory because the cache memory is actually beside him. So there are different level of caches we are having. These are the L1, L2, and L3 level caches. So now the question is here that why we are having the different level of caches, why we are having that L1, L2, and L3. So there are actually there are also, I mean, the reason behind it. So it's first we should have to know that L1 is the primary cache and internal cache. L2 level 2 or L2 is the external cache or advanced transfer cache. L3 not built into the microprocessor. So the level of caches we are talking about, the reason behind it is that I mean when that first this problem has been occurred that okay it is my the CPU and it has been the RAM, so we know that the RAM a bit far from that the CPU, so to reach to the RAM maybe it needs to be crossed the not bridge for example. So I mean the path, I mean the distance between these two devices, two components are a bit far. So when that it has been find out that actually it takes CPU is doing some operation, and on that time operation, if it needs one operand, it must need to be searched to the memory, go to this memory for finding that operands, and he is actually getting that the main memory RAM must need to be find that operands. So what that the operands can be, so that for doing an operation here, the CPU requires 1 to 9, the information. But when he is actually doing the operation, he is there is the operand is missing, say 8. So he is not finding that the 8, the operands. So that means the operation cannot be continue. Up to 7 he has done. So he must need to be pause his operation, and he need to be asked to that the RAM that okay, give me the operand. So when it comes to the RAM must need to be find it out that where is that the single operand 8 is. So it is going to be take a bit time to find it out, and then when it find, then it is going to be sent back to the CPU, the 8. So when that the CPU get the 8s, then only he is going to be replay the operation to complete it. So the time it has been taken for sending the request from the CPU to RAM and replying from the RAM to the CPU. So on that time, CPU does not do anything. So that is what it is a waste of the CPU's power, right? So we always need to be try that okay, the CPU must continue its work. CPU must run. CPU must do the operations. So this is what with the feeling of that, a cache memory concept comes, and it has been done that okay, single cache memory has been given inside of the processor. Actually, first it comes out of the processor. It was not in the processor, but it was beside the processor. So that the beside the processor. So when this cache memory has been given, so that this is the L1 cache. So when the cache memory has been given, so now the same operation that the CPU is doing, that 1 to 9, 8 is missing. So the CPU is not will go to the RAM. It is going to be asked to the cache memory L1, but do you have that 8? I need it. Or continue the operation. So L1, if it has, L1 immediately is going to be give that operands 8 to that the processor. So that is what I mean. CPU does not need to go to the RAM, so the time is going to be saved. The 8 has been going to be gettable from the cache memory, and immediately that is going to be the CPU can actually immediately continue its operation. So that is the advantage. So when that the operand in this example 8 is already in the if it is in the L1, and he is giving back that the operand to that the CPU, so that is we call the cache hit. What do you call cache? We call the cache hit. That means it is there inside the cache. If it is there inside the cache, then we call it cache hit. But if it is not there, then we call it cache miss. Cache miss. So this is what actually the cache hit and cache miss is. So if the operand the CPU is looking for, that is 8 in this example, then the L1 must need to be go into the RAM for finding that the 8. So that is what it has been found, that when the cache memory has been given, the CPU's performance a bit improved. That means most of the time the L1 is having that the operands that the CPU is looking for. So what is going to be there? So that is what I mean. When it has been given the level 1 cache, so it has been seen that okay, somewhat the CPU's performance has been improved. Then later on it has been thought, okay, that the L1 cache memory we are giving, that is actually the very small size. It was very small size that the cache memory we had. So with that the small size of memory, yes, it was I mean improved to that the performance of the CPU, but with this small size of memory can be increased, right? The size of the memory, the cache memory can be increased, but it has been found that of course that the memory is going to be useful if it is having the less number of operands. If you are giving that the bigger size of the cache memory, then it is not going to be useful that much, because you know that you are doing the doctor is doing an operation and he needs that the immediate help. So for example that the doctor is doing an operation into the operation theater, and he's asking, give me a scissor, extra scissor, and the sister must need to be provide the scissor immediately. Okay, if it is not there, then the nurse must need to be go outside of that the operation theater. So it is going to be take some time. That is going to be hamper for doing that the operation. So this is what that I mean. It has been thought that okay, the level one. This is the cash one level one cash I'm giving. It's not enough. So we if you're increasing this, that is not going to be also good. So that is what they have done. They have bring that the another level of cache. So that means now it has been separated like this. So if I am having that the L1 cache, then I am giving also the L2 cache. So that is going to be the two cache memory. If it is my CPU, if it is my CPU, then it is my L1 cache, and beside that L2 cache has been given. Here I have the RAM. So what is going to be happen now? That okay, the same operation that the CPU is doing, searching from 1 to 9, and 8 is missing. So if for that the 8, he is going to be check that the L1. So if that the L1 is having this 8, he is going to be immediately respond. But if it is not there, that means it is cache miss. It will move to that the L2. So it is going to be checked now that in the L2 that the required 8 operands is there or not. If it is there, then he is going to be immediately respond, and from that the L1 it is going to be given to that the CPU. So now that L1, this is also the I mean smaller size of cache memory, but somewhat this can be a bit bigger size than the L1 cache. So this is what has been given, and when it has been given, it has been found that okay, the CPU's performance is more improved. So therefore that again there are another level of cache they have thought, that is the L3. So that this way they have given the L3. So similar thing that I mean if that the 8 in this operation is not into that L1 and L2, then it is going to be asked to that the L3, do you have that? If it is have, it is going to be sent to that the L2, so that the L1, and so that the CPU will get that the operands. So even I mean if this the I mean the operands is not be found in L1, L2, and L3, it must go to that the RAM for searching that the operand the CPU is looking for. So that is what I mean. The cache memory is very useful because it has been found that more than maybe the 97% or 98% time the CPU is getting the operands he is looking for from the L1 or L2 to or L3. Most of the cases it is there. So that means it is actually real useful thing for the CPU to do with the some of the instructions operations. Yeah. So later on, I mean, it has been also thought that how to give that the L4, right? So I think it has been also implemented the L4 level of level 4 cache. But you know that I mean it is not simply like that. I mean you are going to be give that 1, 2, 3, 4 the level of cache you are increasing, and it is going to be actually all the time. It's going to be a good idea. Okay, why? Because look that the CPU is looking for something. He is first asking to the L1. Is it there? No. It is not asking. It is asking to the L2. L1 is asking to the L2. Do you have this? No. If you're having this here, do you have this? Level 3 is saying no. If you're having this level 4, it's telling no. That means you have to go to the memory, RAM. Okay. So that means the time you are taking for checking that the instructions from the CPU to the 1, 2, 3, 4, and if they are not there, then it is going to be take actually a longer time to switch from level 1 to level 2, level 2 to level 3, level to level 4. So it is going to be kill you longer time. So that means it is better than directly go to the RAM rather than checking this L1, L2, L3, L4. So that is why it has been limit to that actually L1, L2, and L3 for your I mean the cache memory. Okay, so this is what actually it is telling that I mean when it has been easily we say that there are 3 level of cache L1, L2, and L3. So it has been actually the two of the level of cache L1 and L2 has been later placed inside the processor, so that the processor needs something, the core, right? We said the core inside the microprocessor. We have the core processing unit, so that the beside the processing unit, cache memory level 1 has been given, even the level 2 has been given, and then level 3 cache actually that is actually built in into that the motherboard. So look at first it has been designed to, as like the RAM. Now we have seen that in the RAM there are small chips. So the cache memory actually developed like that first time like that. These are the chips, the black color. So like that on that the board the cache memory has been come to cache memory L1 and L2 inside in a board, and that actually we have installed in the slot of the motherboard. So but later on the level of cache has been bring inside of that the microprocessor. So the level 1, level 2, those caches were inside of the microprocessor, and level 3 has been given into that built-in into the onto the motherboard. And then later now these days all that the level of caches, level 1, level 2, level 3, actually they are inside of that the microprocessor itself. So that is what I mean, this level of cache memory. I think these are the discussions I'm giving you here, that the detailed discussion actually into that the processor lecture. Okay, so this is what do you understand this?
Yes, sir.
Yeah, so it's very interesting topic, right? I mean, this is the cache memory concept has been used in many sectors of computer science and engineering measures. Okay, so the next one is coming the flash memory. So with that, the flash memory or that the flash RAM, that these chips can retain data even the if the power is disrupted. So yes, I mean the flash memory, that the flash drive, USB drive, right? So like that the you are having that uh, different applications like that. I mean, for that, the your digital camera, that you are having that the smartphone that we are having actually this type of RAM inside of these devices that I have mentioned. So this type of devices is actually capable to store the information inside of that the memory itself. I mean, you can read, you can write, you can rewrite, you can remove, you can add, so something like that. So these are the flash memory. This concept actually using the both of the concept like that are using that the both of the technology that we have used for the RAM as well as for the cache memory. So that means dynamic RAM and the static RAM. So that this memory is going to be a bit expensive. That the reason behind it, because you're storing that the informations. It is going to be stored that the informations actually you have saved. So this is what this is going to be used for this different purposes. And then we are having here the memory capacity. I think that we already know that megabyte equals 1 million bytes, gigabyte equals 1 billion, and terabyte means 1 trillion. So this is what we already know, that the memory capacity. So that the memories we have in the computer, like hard disks, like RAM. So actually we are, I mean, the measurement, the unit of that, the size, the memory size is going to be determined with kilobyte, megabyte, gigabyte, and terabyte. So this is just simply showing a table, nothing else than that. So now it's coming ROM. Okay, so we have already said that ROM is a fixed up instructions. ROM is a firmware, you can say that. CMOS is a firmware, you can say that, right? So that the firmware, we know that the firmware is actually combination of the hardware and software. So that is what in that the hardware, actually the programs, some of the programs, the fixed startup programs, instructions are going to be stored. So the ROM chips are not volatile and cannot be changed by the user. Okay, so that means this is non-volatile memory. So what does that the non-volatile memory means? That means it is going to be stored the information, that the information inside of that the ROM we are having instructions inside that the ROM we are having, that is not going to be erased, and even that cannot be editable by that the human. So it is telling that ROM chips are not volatile and cannot be changed by the user. That's why I say it cannot be changed by the user, because instructions are fixed inside of the ROM. CPU can read and retype data and programs, but the computer cannot write. So this is that the ability of that the CPU, right? CPU will be able to do read or retrieve the data and programs of that the ROM, but the computer itself cannot actually write anything onto that the ROM. So this that the ROM is going to be contain them some of the special instructions that is the needed to start the computer system, give the keyboard key special capabilities, and put the characters on the screen. So these are the facts. Few facts have been mentioned here, that how the ROM is going to be useful when we are going to be use the computer system. So yes, of course, that when you are going to be start up the computer system, ROM is going to be taken to part of the startup, fixed startup instructions. With the fixed startup instructions, ROM is going to be give the capabilities to your keyboard so that actually you'll be able to use them, right? Like that special case, we say that for entering into BIOS, for maybe for entering into that DOS mode, or maybe that when you are going to be going side of that the Windows, the keyboards getting that the accessibility that is from the ROM, so then so on. And then the put characters on the screen, that we understand that this is what that I mean we can actually type. We can actually, when you are going to be going inside of that inside of the CMOS setup, you will be able to change the settings over there, and also will be able to see that different characters over there, and over there you will be able to write, over there you will be able to read. So that is the accessibility is going to be given by that the ROM. And that the CMOS, that the next one, in case of the CMOS, we have seen that, I mean, we have already said it, that this is for the flexible startup instruction. So this is what that the ROM chip is actually that is the complementary metal oxide semiconductor chips provide flexibility for a computer system. So I already said it into that our lab class, that okay, it is going to be contain the essential information that when you turn on the computer system, it's like that the date and time, right, that of the computer system is going to be always correct because of the decimos, and the amount of RAM, that how much RAM you are having into that your computer system, and type of keyboard, what are the type of keyboards you are having in the computer system. So this actually stored by the CMOS. So we have already said into the lab class that okay, the BIOS difference between the BIOS and CMOS. We said that the BIOS configurations are going to be stored into the CMOS, and these informations are going to be stored there real time, and these informations are going to be saved there because there is a battery is there inside of that on the top of the motherboard, that we call the CMOS battery. So that is what actually this contents, these essential informations are going to be, I mean, always there, and it is going to be correctly running. The content can be changed or to reflect changes in the computer system. Yes, that is also another factor. This is going to be happen. You know that we say it about the post power on self test. So when actually you are changing something onto your computer system like that, if you are increasing your RAM, you are having the 2 GB RAM, you are I mean increasing the 2 GB RAM, so that your computer system is going to be detect that it is going to be found that you are have added the extra RAM. If you are adding an extra hard disk, if you are adding something extra, like you are adding a new keyboard, you are adding a new mouse, so that the computer is going to be able to understand. So the BIOS is going to be automatically detect them and store that the information into the CMOS, so that the CMOS is holding the instructions that can be actually changeable, that can be actually that is going to be automatically changed if you are changing that your computer specifications, if you're I mean changing some components of the computer system. Is it clear?
Yes, sir.
Yes, sir.
Okay, that's good. That's good. So this is what actually that the CMOS is, and then it is coming about the system clock. So this is the last example for that instruction 3 plus 5. We have seen a couple of the examples already. So that the 3 plus part, we are talking about the system clock. So we are talking about the oscillators into that the lab class. So the oscillators are creating the vibration, and actually it is going to be sent it to the system clock. So that the system clock is nothing but it is talking about the system speed. So it is what it's saying. The system clock is an important measurement indicating the computer speed. So how much fast your computer is, that is going to be determined by the system clock. So it say it located on a small chip that provides precisely timed electrical beats. So that is what I mean, that the electrical beats we are talking about. It's like that like our tick 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 that analog watch is giving that the sound tick 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 tick, right? So this is actually some sort of the beats, or maybe that band beats. Okay, with the stick you are hitting one time in the band, so ting ting ting, something like that. So here, I mean, this is going to be located on a small chip that produces the precisely timed electrical beats. So based on
Hello,
that the beat,
sir.
yeah.
Sir, I joined late, so I could not give my attendance, sir.
Yeah, if you're coming to the class late, you'll not get the attendance, you know
No,
that.
sir. I'm trying to get in, but my internet was very slow. That's why. That's why I even messaged in class.
Yeah, so I mean, if you are late in the, if your internet is slow, you can keep that the backup, right? You can buy an 1 GB or 5 GB or 7 GB internet if by using your mobile operator, right? Because I mean, this can be happen. In my case, also it happens that I'm taking your class. So if my Wi-Fi is not working, so the class is going to be suspended. No, I should have to use my mobile phone. I should have to continue that lecture. Otherwise, you are not going to be get the lectures. Do you understand that? So I mean, always you should need to be have the backup with you. Second plan. So these days actually that the GB is also not so much expensive. I mean, with 100 taka, 150 taka, you can get 10 GB, 10 GB internet for a month. So it is not only about a single course. It is about that all the courses that you have taken into the semester. Do you understand that? So you
Yes,
should not miss out the lectures. You should not miss out the attendance, lectures, anything during the semester. So you should need to be think about a backup.
no, sir. I buy in some internet and now join the class.
Right. So do it early. I mean, and buy the internet for a whole month. That is going to be cheaper.
Okay, sir. But please, sir, can you consider today's attendance?
Later on, look that this is also disturbing. That the we are discussing about the study, but you are talking about your attendance. Whole class is waiting. Get it or not?
Yes,
So
sir.
please, all of the students, please make sure that you are having some backup so that you are coming to the class on time. Okay, anyway, so we are talking about the system clock. We say that the system clock is going to be measured. That actually that is the computer speed. We say so that the computer speed is going to be measured with the gigahertz. Okay, the billions bits per second. So this is what the more gigahertz you are having for your computer system, then that means it is going to be give you the that your computer is going to be more powerful. Okay, that the system clock is going to be measured that your computer speed, so that the more gigahertz you're going to be have with your CPU, that you are going to be have the more faster performance. So that is what it's saying, that the faster the clock speed, faster the computer can process the information. That is what. So it is talking about that. I mean that the speed measurement of the computer system can be determined by the system clock. So that the system clock you're having, with that the system clock, your CPU will be able to work with that. I mean the your commands or your instructions. So that is what it is talking about, that more faster clock speed you are having, that means most gigahertz, gigahertz of power you are having into your processor, that is going to be able to work more quickly. It is going to be access the informations more quickly. So that is what that the gigahertz. I mean, you know that. I mean here that the example has been given for 3 plus 5. So look that for doing that the operation 3 plus 5, it needs that the 4 bits, right? So that the bits we are talking about here, here, right? Bits per second. So that the bits we are talking about here, that is actually, you can see that we are having that for a basic instruction cycle. We are having that the 4 steps: the fetch, decode, execute, and store. So it is going to be deal with these instructions with that the 4 steps. That means we need the 4 bits for completing these instructions operations into the processor. But these days the computers are multi-scalar. So that means we know that inside a processor we are having the more cores, the multiple cores. So that means in a single bit, these days computers actually can deal with the several instructions at the same time. In the single bit, the more instructions can be executed in the computer system, because now we are having that the multi-scalars processor, multi-scalars technology. So that this is going to be, the performance is going to be far better than this uni processor that actually we had before. Now we are having the multi-core processor. Okay, so that means parallelly the words are going to be given, and that means in a single bit that lot of, more than one instructions are going to be executed into the computer system. So that is going to be more useful, that you are having that the more speed, that the gigahertz. So that means you'll be able to deal with that the more inform quickly. You'll be able to finish that the excess of the instructions into your computer system. So next, it is talking about the expansion slots and cards. So you have already know that we are having the several extension cards, extension slots into our onto our motherboard, right? We have seen that the PCI slots. We have seen that we are having the RAMs, extra RAM slots. We have seen that we are having a special graphics card slot. right? So there are different slots are there. So it is talking about that allow the new device to be added. The expansion slots and cards are going to be allow you to add the new devices into your computer system. So this is what it said, that the open architecture. So the open architecture, you know that your desktop computer is an open architecture. So that means there are going to be some of the facilities with that the different slots that later on you'll be able to improve the power of your computer system. That means if you want later on you'll be able to add a RAM, you'll be able to add a graphics card more for the more graphical performance. You'll be able to add an extra hard disk to increase the capacity of your storing data. So and you'll be able to add the better sound system or better sound card. So this is what actually this is possible because your computer system is open architecture. So slots provided for expansions that I already explained, that we are having the different slots, and that the slots we are having, or that the slots we are actually there are different types of cards are there that we call the expansion cards that actually are going to be installed onto the slots. So that the telling that expansion cards are also called plugin boards, controller cards, adapter cards, interface cards. So this is the another name of the expansion cards. So it can be called with any name. So this is that what actually we have learned that on the motherboard we are having the different slots, and that are for that the future extensions. So that is the desktop computer system. We get this opportunity to extend our computer system performance. So that is what I mean. These slots are going to be give us chance that okay, we will be able to upgrade our PC according to our demand. That means the cards are going to be the expansion cards we are going to be buying, and they're going to be installed into our PC onto that the slots. That means, of course, that our computer system is going to be more powerful, or more advanced, or more upgraded. So here it is showing you that some of that the commonly used expansion cards. So we have already talked about them. The advanced graphics cards like PCI EX16, 32, or 64. The sound cards that is going to be installed into that your PCI slot. This is the PCI EX16 or 32 or 64. And then we are having the modem cards that can be actually installed into your PCI slot. Then you are having the network interface cards, NIC card, LAN card. LAN card is going to be able to install your PCI slot, normal PCI slot. Then we are having that here PC cards. The PC cards is like that actually. It has another name, the PCMCIA, personal computer, personal computer. If I'm not wrong, this is the personal computer memory card international association, something like that. It must be. Okay, so this is the card is going to be is like that. Okay, so you will be able to actually use this card for installing into your computer system. So that is actually going to be stored that the different informations of that your data and program. So the TV toner cards that can be actually also explained into the your normal PCI. So that is what actually it is showing some examples that okay, that the expansion cards you're talking about that are going to be installed into the expansion slots. So these are the slots and these are the cards. So these slots, I mean, which type of cards are actually there? Commonly used expansion cards are there that has been given some examples. So here already the bus lines we have discussed it. We have already said that actually the bus lines here that the different lines we can see drawn on the board. So with that the bus lines actually we know that CPU will be able to reach to that the other components of the computer system, and the other components is going to be able to reach to that the CPU. So that the bus lines we have already said that it is known as the info path. So it's like that the lane. So you can see that data roadway for the traveling bits and measured as the bus wide and more lanes faster traffic. So that is what so that the bus wide is going to be important. It is a one lane road, so that means the car need to be go serially. If there are two lanes are there, that you'll be able to cross. I mean that that is going to be two line of the vehicles. If you're having three, then you're going to be have more. So that is what it's saying. The more lanes you're having, the faster traffic you will get, because with that the more lines, that if you're having the three lines here, so that means signals are going to be passed to all three lanes, all three bus lines. So that means multiple lane bus lines is going to be held to bring to carry that the signals from a component to the other component easily. There are two types of bus lines you are having that are called the system buses. That is usually from that the you have already seen that the block diagram of chipsets. So you have seen that the system buses actually is on top of that the chipset, the NOT bridge. So there you have seen that the communications between the CPU, memory, and AGP slots, the graphics slots. So these are the system bus. These are known as the system bus, where actually most of the traffic is going to be there into the computer system OS. And then that the expansion buses are there. So actually, this is the some of the expansion buses it is talking about. So there, the expansion buses is going to be for the expansion slots, expansion cards. That actually the PCI, the peripheral components interconnect places, right? So on there, actually peripheral devices actually for peripheral devices. That is going to be actually the expansion buses are going to be there. So there are different type of peripheral expansion buses are there. So you can see that peripheral component interconnect the PCI buses. So through that the PCI buses like that in the PCI buses, which card you are explaining? Installing that you are installing like that the sound card, like that the your LAN card you are installing, right? So that through that the PCI buses, these cards are going to be able to communicate with the rest of the computer components. And this is a common one, that universal serial bus, the USB. So that is also the expansion buses, right? So with the USB actually will be able to reach or connect any device with the computer system. So keyboard, mouse, these are the different devices actually you are using that actually will be able to directly connect with that the USB connectors, right? So extension can be done with that to the USB connectors. Extension of the computer system can be done with that the USB connection. So that the USB connections you are using, that actually you should need to be used at the USB expansion buses. So USB buses, so that the bus lines will be able to, I mean, communicate with that the rest of the other components of the computer system. Now here you are having the fireware buses. The fireware buses is going to be actually high performance serial bus, and that bus is actually used for digital camcorders or the video editing software. So this is that the high performance serial buses you need for that the some special devices. So that the fireware buses is actually that this the fireware port. This is that the fireware port is actually very common from that I think this is actually recent, not too much ancient or old discovers. So this the fireware buses is actually very much useful to transferring that, I mean, the data or information very fast from a component to the other component. So if you're connecting to the fire buses, if you're connecting the digital camcorders or video editing softwares, the data is going to be very fastly moved from a part from a component to the other component. The serial advanced technology attachment, so serial that we have learned, the SATA connectors. So yes, we have learned through the SATA connectors. Actually, we are with that the SATA cable, we are actually connecting the one part of the SATA cable into the SATA connector, another part actually with that the peripheral devices like optical drives, like that the DVD, like that the hard disk, right? So we are actually connecting that. I mean, on that time we are going to use that the SATA buses. And then that this is the PCIe. So we already know that is nothing but the peripheral component interconnect express PCIe, right? So PCIe express 1632, PCIe X1, PCIe X1, A, PCIe X1, B, right? There are smaller size of expansion express slots are there. So this is what actually for this the different expansion devices or expansion components actually we are going to be used that the expansion buses, that the expansion buses we're talking about here. Clear?
Yes, sir.
Okay. So can you please unmute your microphone, all of you?
Yes.
Sir.
But then after Molly Mostly Hassan is not here. Doiti is not here. She's always like that. Doiti. Okay, mute your microphone. Mute your microphone, please. Laila, all of you. Mihir, Afrus, mute
Yes,
your
sir.
microphone. Mute your microphone, all of you. Rasel Molla, mute your microphone. Okay, now here we are talking about that the ports, right? So that the ports we are talking about here, that the port is a connector on the motherboard or a separate adapter that allows external device to connect to a computer system. We have already seen that example of the ports, the back panel, right? The last slide we have discussed into our motherboard topic, that is actually showing us the port. But here, so we know that what is the port. So port is a place, or port is a component. With that, actually, we are connecting the different external components with the computer system. But here, there we should have to. There's some additional information is here that it is talking about. In other words, ports can connect directly to the system board, or they can connect to the cards that are actually inserted into the slots on the system board. What does it mean? It means that, I mean, it can happen that, okay, that the ports can be come with that the motherboard directly built in from that the directly it is coming from the your motherboard manufacturer, like that. The USB drive, for the USB drive, not USB drive exactly. So you can tell that the sound system that you are having, I mean the built-in audio card that you are having on the board. So what you are getting that ready-made port right at the back panel. So you'll be able to actually connect the speakers or headphone on those port, right? So you are having the monitor, for the monitor connector, that you are having a DVI port or VGA port. So that the VGA port you are using, so that is actually also built in with the motherboard. So it can be still in that it can become on the with the motherboard itself, and some of them are going to be with the cards, like that. If you are having a LAN card separately of your board, then you are installing into that the PCI slots. So that means there is going to be the RJ45 connector. So where actually you'll be able to connect the RJ45 cable, right? That the internet cable that is actually make the connections with the internet. So this is how that, I mean, it is telling that it can come with directly with the motherboard, or it can be happen that an expansion card, external card you are installing onto that the uh, one of the slot on the motherboard, that with that actually the port can also come. So it is telling that male and female ports have pins and holes to make the successful connections. So that is what we understand, that, I mean, that one part of that the connector is going to be the female port, and another part of the connector is going to be the male port. So that actually we have to connect. I mean, like that. I mean, here, like that. I mean, for example, that the speakers, the game port, the speakers, any one of that, actually in engineering concepts or any daily life concepts, that it is coming with that the informations of male and female. So I mean, you'll see that there are going to be some female ports and there are going to be some male ports. So that is what that, I mean, we will be able to connect something with that. I mean, some device with the other devices. So that is what actually it is talking about. And here we are seeing that there are different types of ports are there. That is known as the D shell connector. You are having the DIN connector. You have the key. So that is that the DIN and D shell connectors it is showing here. So this is that the DIN connectors. It is actually especially talking about the mouse and keyboard that we can see here. And we are having the D shell connector. Then the D shell connector, on the D shell connector, we can see that we are having like the serial connectors. We like that we are having that the parallel connectors. So that the different connectors have been coming actually that the different type of ports. So you are having the game ports that is actually different from that also that the DIN connector that we are having. So here it has been said that what is the D shell connector and D connector is. So if you are studying this, the D shell connector, a connector with more pins or holes on the top row, then on the bottom row. So a cold cable can be only attached into one direction and not accidentally connected by the wrong way, generally represented with the letters DB, right? Letters DB. and the number of pins such as DB9, DB15, DB25. So that is what actually these are the D shells you are talking about. That is coming with that the almost you can see if you're looking to that the shape of that the connectors, then you'll be find it out that it is look like the D. The shape is D, and with that the different number of pins. These are the two, both of them the female connectors, and these two are actually the male connector. So this is simply going to be, I mean, as because of the shape is D, so simply you will be able to match with that the female connector to the male connector, so that the connection can be easily made. The DIN connector here it is talking about, this is actually round type. So this is the fact you can see here that the mouse and keyboards are with the round shape. Then these connectors are known as the DIN connector. So round with the small holes, normally keyed. So what is the key? A connector that has the extra metal or plastic piece or notch that matches an extra piece or notch on the cable. So it can be only be installed one way. So that the here you're seeing that there is a bit bigger size of hole than that the smaller hole all around. So that the bigger size hole is actually the key. So that when you are going to be installed, that your keyboard cable, these days it is coming with the USB. But if you are having the PS2 connections with your keyboard, then you will see that on the connector there is going to be a plastic piece inside of the connector. So that the plastic piece is going to be need to be matched with that the key. So that I mean there is other pins you do not need to check. That just you need to check that the bigger pin. So if you are seeing that the bigger pin that you are going to be maintained with that, okay, how I'm going to be connect that with that the computer PS2 connector with my keyboard cable connector. So it is going to be easy to actually connect this. So this is what it's telling, that the keyboard and mouse are usually this type of connector with each either 5 or 6 pins. So that are the 5 or 6 pins. Usually the 6 pins are going to be there these days. So this that the fact actually we are seeing here that okay, and we are finding that actually differences with that the DIN and D shell connectors. So that with that the D and D shell connectors, we are going to be connect the different devices to the cable connector level. So here we say that there are two types of ports we are having here. That is called that the actually the 4 types. But here it comes to me that the 2 parts, basic two types. One is the standard ports, one is the specialized ports. So in case of the standard ports and specialized ports, so what is the difference? So in case we are having the 4 common ports we are for that the computer system. What are they? Serial port, parallel port, USB port, firewire ports. So you can see here these are the standard ports actually going to be. You can say that these are the standard ports we are having this the 4 common ports. So that the standard ports for the serial port. So the serial port, the parallel port. So the serial port is going to be used for what? Look at this is my serial port. So that the serial ports is going to be used for a purposes. The parallel ports are going to be used for a purposes. So serial ports usually actually are going to be used for that connecting that the keyboard or mouse. But in case of that the parallel port, that you are going to be used for like that the printer. So for connecting that the printer, you need the parallel port. So you are having some the serial ports like that the PS2, PS3, PS2 keyboard, mouse, and then you're having that the USB ports that for connecting that the USB devices. These days actually all of the mouse, I mean all of that the things, all of the devices like that the keyboard, mouse, printer, right? That all of the devices actually we are using the USB connectors. So you are going to be use the firewire port. So you can see that Hydra port, that is actually the specialized port. The firewire ports actually is not showing in here. So I have already said that is actually special ports that is going to be used for connecting the camcorders. It is going to be, I mean, faster data transfer between that your camcorder and the computer devices. So that is the firewire ports can be there on there. So these are the specialized, some of the specialized ports like MIDI port, SIA port. So these are the specialized port, Hydra ports. So for example, here it is shown that the Hydra port, you are having an Hydra port. So with that the Hydra port, what is actually it is called the infrared in infrared data association. You call that infrared communications. So that means it is actually going to be wirelessly connected. That your computer and your maybe smartphone or maybe your laptop will be able to communicate with the short distance with the infrared technology. So you should have to make sure that, I mean, when you're connecting them, we are actually connecting from one mobile to that another mobile with that, I mean, for transferring some data, big size data. So on that time, actually, we are using the infrared technology. So we should have to make sure that there is no barricade beside of these two devices. We should not be. I mean, we should have to be make sure that the when we are detecting that we are trying to transferring some data, we should have to make sure that okay the mobiles or that the computer laptops are actually into a free space so that there is no block, there is no barrier of that the transmission, the wireless transmission. Otherwise, the transfer is not going to be done. That is what I mean. The infrared technology is going to be used for actually transferring the data wirelessly from a device to the other device. So MIDI is for that the media instrument digital interface. MIDI is for that the media musical instrument is going to be used like electric guitar, electric piano, something like that. And the small computer system interface, that is that the another technology is going to be this technology is actually making that the different components with that the smaller computer system interface, so some a smaller size of that the devices they are actually creating for connecting with that the computer system. And this is we are having so I think we are going to be finished here up to this 46. Okay, we have more 10 slides, so we are going to be able to finish it in the next class. Okay,
All right, sir.
so do you have any questions here?
No, sir.
Okay, so